Okay.
Okay, so the mass of the atom is due to the proton and neutron. And this proton and neutron exist within this atom. So we can say that majority of the mass of an atom is concentrated in its center.
Okay.
In its nucleus, and nucleus is present in within the center of the atom. So part A done, which was asking for the two results that were inferred from the alpha particle scattering experiment. So nucleus is positively charged, and the second one is majority of the mass of an atom is concentrated in its nucleus. Now part B, an alpha particle is made up of other particles. What it is saying, an alpha particle is made up of other particles. It is a composite particle, therefore it is made up of other particles. One of these particles is proton. State and explain whether a proton is a fundamental particle. What do you think?
Fundamental particle और है.
Fundamental particles are those particles that cannot be broken down into anything. Means they do not made up of other particles. Composite particles are those particles that are made up of other particles. We have discussed this many times. The difference between fundamental particle and composite particle. The particle family, if you remember, there are two types of particle family: mesons and barons. Mesons are basically the quarks, the electron family, and the barons includes the hadrons. The other family was the hadrons. Inside the hadrons, we were having what we was barons, and barons were basically protons and neutrons. So proton, if you remember the quark model of the proton, what was the quark model of proton? We were having two up quark and one down quark. Remember that? The
Yes.
quark model of the proton. So proton itself is made up of three quarks. So it will be a fundamental particle or a composite particle.
Which?
These up quark and down quark are known as fundamental particles. These quarks are known as fundamental particles. They cannot be made up of anything else. They cannot be broken down to anything else. But this, when these three combine together, they form a proton. So proton is made up of quarks. So it will be not a fundamental particle.
Okay.
And what is the concept of, now it is clear what is the concept of fundamental particle. So proton is made up of quarks. So this question we have done before also. How we prove this thing? We say that proton is made up of quarks, so it is not a fundamental particle. So what it is? It is a composite particles. So the particle that are made up of other particles. Other particle include quarks, up quark, down quark. We have studied the six flavors of quarks. So not a fundamental particle.
Okay.
A radioactive source produces a beam of alpha particles in a vacuum. The average current produced by the beam is 6.9 into 10 to the power minus 9 ampere. So calculate the average number of alpha particle passing a fixed point in the beam in a time of 1 minute. See here, we are given with the time and we are given with the current. Time and current. What can I do? Any formula that comes in your mind, if you have studied electrodynamics, what is the formula of current? Current equals to
V equals IR.
R upon V equals to IR. It is a
Yeah.
ohm. I'm only asking that current is basically the rate of flow of charge. So rate of flow of charge
Yes.
means charge upon time. So what is given? Average current is given and time is given. Okay, so first of all, try to understand what is the scenario given here. We have a radioactive source. There was a radioactive source that was emitting alpha particle. Okay, that was emitting alpha particle and in a vacuum. Okay, that is a medium. The average current produced by this beam. So this beam when was moving, okay, so alpha particle is basically a charge, and when a charge moves, what it creates current. The flow of charge is basically known as current. So when this alpha particle beam was moving, it was creating a current of this much ampere. Calculate the average number of alpha particle passing a fixed point. So there was a fixed point here. We want to find that how many alpha particles are passing through this point in a time of 1 minute. For 1 minute, how many alpha particles pass through this point? This is basically known as current, the flow of charge per unit time passing through a point. So therefore, I use this formula I equals to Q upon T. From here, I can calculate the charge that is passing through the point, through this fixed point. Yes or no? I know
Okay.
that the
Yes.
average current at that point was 6.9 into 10 to the power minus 10, and the charge I don't know, and the time was 1 minute. 1 minute means 60 seconds. Where is the calculator? So 60 into 6.9 into 10 to the power minus 9 will become charge equals to 4.1, 14 into 10 to the power minus 7 coulomb. Now what it is asking, number of alpha particles, and what I have calculated, the charge. I have calculated only the charge. So how can I calculate the number of alpha particle through charge? So that's not a big deal. Let's understand the ratio. There will be some ratio method will be used. I know that one alpha particle have a charge of how much coulomb? Remember, one alpha particle have
Yeah.
a charge of
1.6 into 10 to the power
no.
minus 19.
That was one elementary charge. I am asking, see, alpha particle. If I talk about the nucleus of alpha particle, the nucleus of alpha particle is made up of 2 protons and 2 neutrons, and the charge on the nucleus is due to the proton. How many protons are there? 2 protons. So that means the charge on the nucleus of alpha particle will be plus 2e.
Okay.
And plus 2e means 2 times the elementary charge, that is 1.6 into 10 to the power minus 90. So this is my total charge in one alpha particle nucleus. What is the charge that is flowing through that fixed point? 4.14 into 10 to the power minus 7 coulomb. So I want to know that what is the number of alpha particle at this charge value. So can I calculate? Cross multiply. I want this x number of alpha particles, x number of x number of alpha particles will be equals to 4.14 into 10 to the power minus 7 divided by the 2 into 1.6 into 10 to the power minus 90.
Okay.
So the answer you are getting is 1.29 into 10 to the power 12. So I will round off to 1.3 into 10 to the power 12 alpha particles were passing through that fixed point. Is this thing clear?
Yes.
So how I connected things? First I saw that there was a current, time, charge calculated. Use a ratio method to find number of alpha particles. Now talking about the part D. Okay, so alpha particles in the vacuum in part C. The alpha particles that were moving in this vacuum in part C now has entered a uniform electric field. What is a uniform electric field? Electric field lines will be parallel to each other. Means the electric field strength will be constant, electric force acting on that particle will be constant for that alpha particle when entered in this electric field. The alpha particle enter the field with their velocity in the same direction as the field. So what it is saying, was my electric field. This was my direction of electric field, and that alpha particle that were moving came and enters alpha particle in the same direction. This was my alpha particle with the same direction, and this was the direction of its velocity towards right. If the electric field was acting towards right, for example. State and explain whether the magnitude of acceleration of an alpha particle due to the field decreases, increases, or stays constant as the alpha particle moves through the field. So it is asking as soon as this alpha particle enters into this electric field in the same direction, if the velocity of the alpha particle is in the same direction as the field direction, so what will happen? Will its acceleration decreases, increases, or stays constant? So this is the question. So
Okay.
my acceleration, if I talk about acceleration, whenever I talk about acceleration, I talk about the resultant force. What is the Newton's second law? The force and acceleration are directly linked together. So if I want to know the variation in my acceleration, I want to know what will be the variation in my electric force that will be acting on that alpha particle when it enters into this uniform field. What will happen? This alpha particle when enters into this field, what is the first thing that will happen? An electric force will act on it. In which direction? Can you tell me?
The which
Electric
the
force
electric field
direction will be towards right. Why? Because it is a positive particle, and we have
and it's going
discussed
towards the
about
negative,
that.
yeah.
Whenever there is a positive particle, that for direction of electric force will be in the same direction as the direction of field. So yes, the direction force will act on it, and that will be the force due to the field that will act naturally on the alpha particle as soon as it enters into the field, and the direction of field is towards right. So that is the one thing that we saw here. So okay, so when it will enter, now tell me, it is a uniform field. Will the value of electric force will change as soon as this alpha particle moves through the field? The value of electric force will increase, decrease, or remain constant.
Which is
I'm saying that this electric force, the magnitude of electric force that is acting on the alpha particle as it enters the electric field. So as the alpha particle will be moving through the field, will the magnitude of electric force changes? Will it increase, decrease, or it will remain constant? The
it's
magnitude of
passing through what? It's passing through what again?
passing through this uniform field, uniform electric field.
Then it will not change, yeah.
Yes, not change. Why? What is the reason? We have seen that in
Yeah,
the
let's see.
uniform field, electric force equals to E times Q. And electric field strength is constant. The charge of alpha particle is constant, so force will be constant. Why electric field strength is constant? Because it is a parallel field. In parallel field, electric field strength is constant. Electric force will also be constant. So if this electric force, which is the only resultant force that is acting on the alpha particle, is constant. So electric force is basically mass into acceleration. This electric force is basically our only resultant force that is acting on that alpha particle, that will be equals to the mass into acceleration. So mass is constant. So what that means? If I want to find acceleration, acceleration will be equals to electric force upon the mass. Electric force is constant throughout my journey. Mass is constant for the alpha particle throughout the journey. That means acceleration will remain constant throughout the journey.
Okay.
So what will be the first thing that I will write here? Magnitude of electric force is constant. Okay. So what
Yeah,
that
okay.
means? If the magnitude of electric force is constant, so our acceleration will also be constant. Acceleration is constant. You can also show the examiner the formula F equals to E cube, and this F is basically ma. So F is constant here, so acceleration will also be constant. So that is an additional thing. There will be no marks on it. The mass will be on these 2 points. First of all, you will tell what is electric force acting on it. Will it be changing or constant? So on this result, what will be the magnitude of acceleration? It will be changing or remain constant. Is it clear?
Yes.
Now talking about part E. A nucleus X is an isotope of Y. Okay, the mass of nucleus X is greater than the mass of Y. Both the nuclei are in the same uniform electric field. So wait a second. Read till here and try to visualize the things. There are two nucleuses, X and Y. X is an isotope of Y. So that means the proton number for both the nucleuses will be same. Yes or no?
Yes.
Mass of nucleus X is greater than the mass of Y. That means that the mass number of X, for example, it is A, and the mass of nucleus Y, for example, it is B. So A will be greater than B. Since mass of the nucleus X is greater, so that means the mass number of nucleus X will be greater than the mass number of nucleus Y. Now the picture is I have drawn here. Now it is clear to me what is happening here. Proton numbers are equal, so Z equals to Z. A is greater than B. Both nuclei are in the same uniform electric field, so they are in the same uniform electric field. For example, there is a uniform electric field. Let me draw here. X is here, Y is here. State and explain whether the magnitude of electric force acting on nucleus X is greater than or less than or the same than acting on the nucleus Y. Now we have to compare the magnitude of electric force on both of these nucleuses. How will I compare that? First of all, tell me if I want to compare the magnitudes of electric force. What is the formula of electric force that is acting on a particle in a uniform electric field? I have written ahead above here. You can also tell me from here. Tell me. Tell me.
From the
What is the formula of electric force?
F is equal to EQ.
Hmm. Electric force equals to E times Q. Now, from this
Yes.
formula, on which two things, on which things my electric force depends? From the formula, you can see easily, you can see that it depends on the magnitude of electric field strength and the magnitude of the charge of the particle. Yes or no? My electric field depends on two things, electric field strength and charge. Now tell me, both the nucleuses are in the same uniform electric field. So the magnitude of E will be same for both of them. Yes or no?
Yeah.
The magnitude of E, the electric field strength will be same for both of the nuclei. Why? Because they are in the same uniform electric field. So now that's mean that the comparison will be depend on my charge, magnitude of my charge. So I have to compare the charge values in order to compare the electric force magnitudes. So from the nucleuses X and Y, which nucleus have greater charge? What will be the comparison of charge? X has a greater charge than Y, X has a lesser charge than Y, or the both of these two nucleuses have the same charge. What do you think? What will be the comparison of charge on the nuclei X and nuclei Y?
The nuclear X and nuclear Y.
Hmm. The charge on nuclei is due to which particle? A nuclei consists of proton and neutron. The charge is due to this thing we discussed here when we were discussing about alpha particle here. That the charge on any particle is due to proton. A nucleus consists of proton and neutron. There is a nucleus X. This is the nucleus Y. Okay. So they will contain some protons and some neutrons. I know one thing that this X will contains more neutrons because it was having a greater mass number. But the proton number will be same to for both of them. we have discussed here that the proton number will be same, but the mass number will be different. And why the mass number will be different? Due to the number of neutron that is present inside the atoms of, nuclei of X and Y. And I know one other thing, that the charge on a nucleus is due to the number of protons. So as in the earlier example, the number of protons in the alpha particle nuclei was 2. So that means it will have a charge of plus 2e. And nuclei are always positively charged. Why? Because due to the positively charged proton. So if both nuclei X and Y have same number of protons, so the charge on both of them will be same. Yes or no?
Yes.
For example, the mass, the charge of the, the number of proton present in the X is 5. There are 5 protons in X. So there will be also 5 protons in Y. For example, there are 10 neutrons in X. For example, there are 8 neutrons in Y. So although the mass number is different, the number of neutrons are different. But my charge is only dependent on the number of protons. So if I talk about the charge of my X, my charge on my X, if proton number are 5, will be plus 5e. And the charge on my nuclei Y will also be plus 5e. Why? Because the number of protons are 5. So that means they have same charge. And if they have same charge, both of them have same charge. And if I try to calculate the electric force that is acting on nucleus X and nuclei Y, F equals to EQ, I will apply this formula on both of these. E value is same for both of them. The value of Q is also same. So the magnitude or electric force will also be same. That will be acting on both nuclei.
Oh, yeah, okay.
So my electric force depends on E and Q. So first of all, I will say that both nuclei have same charge due to same number of protons. Both nuclei have same charge. And you can write the reason here, due to same number of protons. Because they are isotope of each other, so they have same number of protons.
Okay.
And in result, you will write the conclusion that, so same magnitude. You have to write to the point, exact, concise detail. I have discussed here few things. Among that few things, I have just written 2 concise points that I think that are the most valid here. You can add up or more points, but remember that you must have to give the valid and concise points. So what was the most important point here? The comparison of charge and the conclusion that there is 1 marks for comparison, that electric force is equal for both of them. This is 1 marks. And the second marks is for the reasoning. Both of them have the same charge. This was the most important reasoning. And I further explained that they were having the same number of protons. So this become a additional point in my answer. So examiner is finding the exact detail, the to the point detail, the more important points in my answer. So if he find it, he will mark you the good marks. So is this part clear? Hmm? Is this clear?
Yeah. Yeah. Can you just go to the first part again? I'll just write it.
First part,
I,
part A,
no, no, no. Okay. I understood. I understood.
this part. Okay,
No, no, I understood.
so
Okay.
we have, okay, so everything is clear. So
Yeah.
now moving towards this question number 5, that is related to electrodynamics. The last question was related to nuclear and particle physics. This question is related to electrodynamics. Define ohm. What is ohm? Ohm is the unit, SI unit of resistance. We measure resistance in ohms. So if I talk about resistance, what is resistance? Resistance equals to voltage upon current. And I want to define ohm. What is the unit? I will define that thing in terms of unit, because he is asking me to define a unit. So I will give my answer in terms of unit. I will explain in terms of units. So the SI unit of voltage is volt, and the SI unit of I is ampere, means current, the SI unit of current. So if I want to define ohm, I will write volt per ampere, per unit ampere. So this will be my definition for ohm. Is it clear? Or you can write volt per unit
Yeah.
ampere. So if, for example, he right here define resistance, so you will write voltage per unit current. So he was asking to describe in terms of unit, so I will describe in terms of unit. Part B, what is it is? Part B, okay. A wire is made up of resistivity P, rho, sorry. The length L of a wire is gradually increased. Assume that the volume of wire remain constant as its length increases. Show that the resistance R of the extended wire is proportional to L square. So let us discuss this thing now.
Okay.
Okay, so there is a one formula that you might have studied in electrodynamics. That one formula was that resistance equals to resistivity length upon area. This formula we obtained by the three relationship that resistance is inversely proportional to a resistance is directly proportional to length. After that, removing the proportion sign, we get a resistivity that is a constant. So this one thing we have studied, that resistance equals to resistivity length upon area. Yes or no?
Yes.
Now, one more thing that you might have studied in mathematics, mensuration chapter, that for any material, the volume is equals to the cross-sectional area multiply the length of that substance. For example, if I talk about cylinder, what is the formula of cylinder? If I want to find the volume of cylinder, that is pi r square h. For example, the height of this cylinder is h and the radius is r. So how we calculated that? For any figure, if I want to find the volume, what I do, first of all, I find the cross-sectional area. For the cross-sectional area of cylinder will be a circle, and the area of circle is pi r square. And I multiply this area by the height. I will get the volume of that substance. This is valid for every substance, regular substance, regular shape substance. This formula is valid. That V equals to AL. L is the height or the length of the conductor. Now it is saying that volume of the wire have remained constant and the length has been increased. So what I want to do here, that I will replace this A by V upon L. What I do, I will replace this A by V upon L. From this formula, can you tell me what is A? If I make A as subject, A will be equals to V upon L. So I will quickly substitute this A in this formula. So R will become rho L upon V upon L. And when you will rearrange this thing, this will become rho L square upon V. Is this clear to you? How we reached here?
Yeah.
R equals to rho L square upon V. Easy, is this thing easy up till now?
Yeah.
Now you can see here that he is saying that volume is constant. Volume is constant. I note that the resistivity for any metal will also be constant. Resistivity is material dependent. So resistivity will be constant, volume will be constant. So when these two things are constant, what are the two things that are changing here? Our two variables will be R and L. So R will be directly proportional to L square when rho and the volume is constant.